Hello there, and welcome to Science for Sleep. I'm glad you found your way here. Maybe you're in bed, your room quiet, the world outside slowing down. Maybe you're somewhere cozy with the lights dimmed, listening while your eyes grow heavier, or maybe you're just here for a moment of calm before you drift off. Wherever you are, this space is for you. A quiet corner of the night where we can set aside the noise and simply wonder. Tonight, we'll take that wondering to a strange question, one that sits just at the edge of science and philosophy, one that refuses to go away no matter how many times it's asked. Are we living in a simulation? It's not the kind of question that needs a quick answer. It's not even the kind of question that really has one. But it is the kind of question that can stretch your mind a little, not in a stressful way, but in the same slow, steady way a horizon stretches out in every direction. Maybe you've had that moment before, staring at the sky and thinking how enormous it is, or sitting in a room and realizing how strange it is that you're even here at all. That's the kind of quiet wondering we'll share. Before we go too far, let me ask you something simple. What time is it where you are? Is it late, the kind of late where the air feels still and the world seems smaller, almost folded in on itself? Or is it early, when everything is silent but full of possibility? Wherever you are, just take a breath and notice the way time feels. That feeling, the awareness that you're here right now, is the only thing we can really be sure of. And that's part of what makes this question so interesting. If all of this was simulated, if reality was running on some unimaginable computer, what would that mean for this exact moment? Would it change anything about the way the night air feels against your skin, or the sound of your own breathing? If you're already starting to enjoy this slower way of thinking, I'd love it if you gave this a gentle like, or even subscribed if you'd like more nights like this, where we can trade the day's noise for questions that don't need quick answers. And if you're listening from somewhere unusual, a tiny apartment in a big city, a cabin in the middle of nowhere, or even just your favourite chair, leave a note. I like seeing where these little pockets of wonder end up. It's like a map of quiet places slowly filling in. Now, let's begin. The idea that the world around you might not be what it seems isn't new. People have been thinking about it for a very long time. Thousands of years ago, philosophers wondered if our senses could really be trusted. They asked if what we see and hear and touch is the full story, or just the version of reality we're able to perceive. One of the oldest examples is Plato's allegory of the cave. Imagine people chained in a cave, seeing only shadows on the wall. For them, those shadows would be the whole world. They wouldn't know about the fire casting those shadows or the people walking in front of it. And if one of them escaped and saw the world outside the cave, this sunlight would almost hurt his eyes because it would be so far from what he thought was real. That story wasn't about computers or technology, of course. It was about perception. But in a strange way, it fits perfectly with the modern question we're asking tonight. Because if reality were a simulation, how would you know? If this room, this sound, this very moment was part of some vast program, would it feel any different? Or would it feel exactly like it does now, simply because that's how the program was written? Take a moment and look around. Not just with your eyes, but with that quiet awareness that notices the texture of things, the way objects sit in space, the way your thoughts keep flowing even if you don't try to guide them. None of it feels artificial. None of it feels like lines of code running in the background. But then again, if it were perfect, if it were designed to feel seamless, why would it? This is why the question doesn't go away. Because even if you don't believe it, even if you think it's only science fiction, there's a part of your mind that has to admit it's impossible to prove one way or the other. And that little gap, that space between certainty and possibility, is where curiosity lives. Some people approach this question like a problem to solve, with arguments and counter-arguments stacked up like building blocks. But that's not how we're going to approach it tonight. We're not in a hurry. We're not here to settle it. We're just here to walk around the edges of it, slowly. Like you might walk through a quiet museum after hours, letting your eyes linger on whatever draws you in. For now, it's enough to simply imagine it. Imagine the room you're in, the bed or chair beneath you, the air around you, every object from the smallest speck of dust to the farthest star, all running inside some vast, incomprehensible system. Imagine that the rules of physics, the way a ball falls when you drop it, the way light bends around corners, are not just the laws of nature, but instructions in a program. And if you picture that for a second, notice how strangely calm it feels. Because even if it were true, it wouldn't change what's in front of you right now. The air would still feel the same, your heartbeat would still sound the same in your ears, you'd still be here. And that's the quiet secret buried in this question. It doesn't take anything away from you. It just gives you a new way to look at things, a new lens to hold up to the world. Now, of course, there are people who take this idea seriously, not just as a thought experiment, but as a scientific possibility. Some of them point to the way mathematics seems to underlie everything, not just in the obvious places like physics or engineering, but in the way nature itself is structured. The spiral of a galaxy, the branching of a tree, the rhythm of your own heart. Everywhere you look, there's order. Maybe not perfect order, but enough that some scientists have wondered, what if that's not just a coincidence? What if the universe looks mathematical because at its core it is? This is where the thought gets more interesting, because if the universe were running on some kind of underlying code, it would make sense for it to be mathematical. Computers, after all, speak in numbers, and if reality was built, then perhaps everything we see is the result of that same hidden language, humming quietly in the background. You don't have to believe that to find it fascinating. You just have to let yourself think about it for a little while, the same way you'd think about the stars at night. You know you can't touch them. You know you might never fully understand them, but there's something comforting in just looking up and letting their distance fill you with perspective. This question is the same way. It's not about solving it tonight, it's about seeing how far it reaches. And if you've ever had one of those moments, when you're standing in line at the grocery store or brushing your teeth or walking down the street, and you suddenly feel like the world around you has a kind of strangeness to it, almost as if it's too precise, too deliberate, you're not alone. Some people call it déjà vu, others call it coincidence, a few even call it a glitch. Little moments that feel, just for a second, like the edges of the curtain have slipped and you've glimpsed whatever's behind it. Of course, there are other explanations for that. The brain is a pattern-finding machine. It's built to make sense of things, to fit the pieces together, even when there's no grand design. But still, the feeling lingers. And maybe that's why this idea is so persistent. It doesn't need proof to exist in your mind. It only needs curiosity. So tonight, we'll follow that curiosity. We'll walk through it step by step, not to escape the world we know, but to see it more clearly. We'll look at the history of this idea, from philosophers who wondered about it long before computers existed, to scientists today who write equations that treat reality like it's something that could be calculated. We'll think about what it would mean if it were true, and also what it would mean if it weren't. We'll take our time, because that's what this kind of question deserves. And as we do, I want you to keep one thing in mind. You don't have to choose a side. You don't have to decide whether it's true or false. You can just let it be what it is. A door that opens onto a bigger room than the one you started in. And in that room, there's space enough to just sit quietly and wonder. Now that we've settled in, let's take our first step into that bigger room. We've asked the question. We've let it hang there for a moment. Now it's time to see where it comes from and why it's been with us for so long. You've probably noticed that some questions don't really fade with time. They don't belong to a single generation or a single group of people. They appear again and again, as if they're woven into the way we think. The question of whether this world is real in the way we assume it is one of those. Even before we could put words like simulation or program to it, the thought was already there, quietly resurfacing in different ways across different eras. It isn't because people enjoy unsettling themselves. It's because the closer you look at reality, the more it slips through your fingers. You take a deep breath, you notice the room around you, and it all feels solid. But then, if you let yourself ask how you know it's solid, if you strip away the obvious answers and keep going down, you eventually reach a point where you can't quite touch the bottom. That's where this question lives. This is not a new place for the human mind. Thousands of years ago, long before screens and servers existed, people wondered if what they saw could be trusted. Some of them framed it in stories, like Plato with his Cave of Shadows. Others shaped it into thought experiments. René Descartes, sitting alone in the 1600s, asked himself how he could be certain that anything he experienced was real. He even imagined an evil demon, a powerful deceiver who might be controlling everything he saw and felt. His point wasn't that such a demon actually existed, but that you couldn't rule it out completely just by relying on your senses. In that way, the modern idea of a simulation is just a new version of an old unease. It swaps the demon for a computer and the cave for a virtual world, but it presses the same nerve. It's the reminder that our experience of reality is always filtered through the limits of our minds and bodies, and that no matter how confident we feel, we're never seeing the whole thing at once. If you stop for a second and think about it, you might notice how often this question shows up in the background of ordinary life. You see it in movies, of course, with their imagined digital worlds and hidden control systems. You hear it in casual conversations when someone jokingly says a coincidence feels like a glitch in the matrix. You even catch it in quiet moments alone, when the world feels just a little too neat or a little too strange for no reason you can quite explain. Part of why it won't go away is that it's not really tied to evidence. It doesn't need proof to survive. It's not pinned down to one single piece of data that you could test and remove. Instead, it lives in a gap that science hasn't filled yet. We know a great deal about how the universe works, but when you pull back far enough and ask why it works at all, or why it looks the way it does, the answers get thinner and thinner. That space where certainty fades is exactly where this question keeps breathing, and oddly enough, it's not always unsettling. For some people, it's even comforting, because if reality were simulated, that would mean there's a structure behind it. A framework, a reason why things are as orderly as they are. It might not tell us who built it or why, but it would mean that the patterns we see aren't just accidents, that every star, every atom, every quiet detail is part of something deliberate. Others see it differently. They hear the same question and feel something heavier in it. If this were a simulation, would that make life less meaningful? Would it reduce all our experiences to nothing more than calculations on some vast distant processor? Would it turn love, memory, and all the small things that matter most into illusions with no weight of their own? But even that worry circles back to the same truth. Whether you find it comforting or unsettling, you can't push the question away for long. You can distract yourself, you can ignore it for days or weeks or years, but it waits. Because it's not a question built on technology or on what scientists know today. It's built into something deeper, the tension between what we see and what we can never quite reach. Think about this for a moment. Right now, you're listening to my voice. The sound waves reach your ears, your brain turns them into meaning, and it feels real because it is. But in another sense, you're only experiencing a small slice of reality. Your eyes see a narrow band of light. Your ears hear a narrow range of sound. Most of what exists around you is silent and invisible to you, not because it's not there, but because your body isn't built to notice it. That's what makes this question so stubborn. It grows out of the knowledge that our senses only give us part of the story. If there's more behind it, if there's something hidden, some vast underlying mechanism, how would you ever know? You'd be like someone in Plato's cave staring at shadows and never realizing there's a fire behind you and a whole world beyond the cave's walls. And this is where the idea of the simulation becomes more than a philosophical curiosity. Because in the past century, science has given us new ways of thinking about the world. It's shown us that everything we see is made of particles so small you'll never touch them. It's shown us that even time itself can bend, stretch, and behave differently depending on where you are and how fast you move. The more we learn, the less solid reality seems. That doesn't mean it isn't real. It just means that reality might be stranger than we expect. And when things get strange, the question slips back in. If reality already works in ways that feel almost unreal, how much stranger would it be to imagine it running on a deeper system of rules so complete and hidden that they feel like nature itself? Even if we never get a final answer, there's something valuable in just sitting with that thought. Not rushing to solve it, not fighting it, just letting it exist the way you'd let a star hang in the night sky without needing to reach it. And as you sit with it, you might notice it has a certain pull. Once you start thinking about whether reality is simulated, you begin to see other questions rising behind it. If it is, who or what would be running it? If it isn't, then why does it feel so perfectly ordered? If we could somehow look behind the curtain, would we even understand what we were seeing? Those questions are the reason this idea isn't going anywhere. They're not just about technology. They're not just about computers or advanced civilizations. They're about what it means to be here at all. And no matter how much the world changes, that's the kind of question we keep coming back to. So, instead of trying to push it aside, we'll keep following it. We'll trace it from the earliest philosophers who asked if the world was an illusion, to the scientists today who wonder if reality has a hidden digital skeleton. We'll look at the clues, not because they prove anything, but because they give us new ways of seeing. And along the way, we'll keep moving forward slowly, letting one question lead us to the next without needing to rush toward any kind of ending. For now, take one last look around. The room hasn't changed. The quiet is still the same. But somewhere, just beyond the edges of what you can reach, the question waits, steady and patient. And maybe that's enough to keep going. If you're going to ask whether the world is a simulation, you first have to look at what the world is. Not in the abstract way people sometimes talk about existence, but in the way that starts with the things right in front of you. The ground you stand on, the objects you can reach out and touch, the air you breathe without thinking. These feel simple, they feel obvious, and yet the closer you look at them, the more complicated they become. Take something as basic as a table. At a glance, it's solid. Its edges are clear, its weight is steady, and nothing about it seems mysterious. But that's only because you're seeing it from the distance your senses naturally keep. If you could somehow shrink yourself down to the scale of its smallest parts, that same table would look nothing like what you recognize. Its surface wouldn't be smooth at all. It would be an ocean of atoms, mostly empty space, with tiny particles flickering in and out of certainty, bound together by forces you can't see. What feels like a single thing is, in truth, a restless cloud of activity. And this isn't just true for tables, it's true for everything. The chair you're sitting in, the floor beneath you, even your own body. Solidness is a kind of illusion born out of scale. It's not wrong, it's just not the whole story. If we lived at a smaller size, if we could see at that deeper level, our sense of what is real would be completely different. This is where the question starts to get interesting. Because if our idea of reality depends on how we experience it, then what happens when our perspective changes? If the table is both solid and not solid, depending on how you look at it, what does that mean for the rest of the world? Physics has a way of answering this, but not in a way that feels any less strange. It tells us that everything you see is made of matter and energy, and that both of those things obey precise rules. Those rules are consistent, dependable, and measurable. They're why your phone works, why the sun rises when it does, why you can drop a glass of water and be absolutely certain it will fall, not float. But the more we've studied those rules, the more they've come to look like something that could be written into a program. Beneath the surface of everyday experience, the world runs on math. Not just roughly, not just approximately, but exactly. That exactness is what some scientists point to when they wonder if we might be living in something constructed. They see the way the laws of physics can be described with elegant equations and wonder why. After all, if the universe were random and chaotic, you wouldn't expect it to be so perfectly predictable. You wouldn't expect it to have this kind of hidden order running underneath it, shaping everything from the path of planets to the way light bends around a star. And yet, that order is there. It's what allows us to launch spacecraft across millions of miles and have them arrive within seconds of their target. It's what lets engineers build machines so precise they can measure changes in distance smaller than an atom. This is what reality gives us when we look closely. Not confusion, but structure. And still, structure doesn't explain itself. You can understand how gravity works without knowing why it exists. You can describe how particles interact without having the faintest idea where the rules that govern them come from. When you start asking those deeper questions, you reach the same place you were before, a point where the ground seems to run out and you're left staring into that same open space of possibility. It's in that space that the simulation idea fits so neatly. Because if the world does run on rules, it's tempting to imagine those rules being part of something larger, something deliberate. You don't even have to imagine it in terms of computers or servers or anything familiar. You just have to see the parallel. Rules feel like programming. Programming implies a framework. A framework implies a source. And suddenly, you're back to wondering if the world is built rather than simply existing. Even if you don't accept that, there's value in the thought. It reminds you how strange it is that reality works as cleanly as it does. Think about time for a moment. You move through it constantly, second after second, without ever having to think about it. But time isn't a simple backdrop, it's flexible. It stretches near massive objects. It slows down if you move fast enough. We don't notice it because our lives are small compared to those scales, but the effect is there. You're living in a universe where time itself bends, and yet you feel like the world is steady. That's what reality does. It gives you something simple on the surface, while hiding all its strangeness just out of view. This is part of why the simulation question keeps coming back. Because the more you learn about reality, the less it looks like a fixed, unquestionable thing. Instead, it looks like a system that behaves according to laws, a system that allows for complexity to rise out of simple rules. And if you squint, that starts to sound like a description of software. But before jumping to that conclusion, it's worth stepping back and remembering that these are only comparisons. Calling the universe a program doesn't explain it. It only gives us a way of thinking about it. That's the same way we used to call the brain a machine when we first began studying it, or a clock, or a network of pipes. The metaphors change as our tools change. Today, computers give us new language to frame old mysteries. Tomorrow, it might be something else entirely. Even so, there's something in this metaphor that refuses to let go. It lingers because it feels close to what we already see, the precision, the order, the way reality can be broken down into measurable pieces that fit together like parts of a design. You don't need to be a physicist to feel that. You just need to notice how strange it is that the universe keeps behaving like a thing that can be understood. And so the question grows. If this world is built on rules, who or what wrote them? If it's not built, why do they exist at all? Those are not questions you can settle by looking at a single experiment or reading a single paper. They are bigger than that. They sit at the edge of everything we know, inviting you to lean forward and look a little closer. When you do, you start to notice that reality doesn't just sit there waiting to be explained. It pushes back. It shows you things like quantum physics, where particles can be in two places at once until they're observed. It shows you the limits of what can be measured, like the Planck length, a smallest possible scale beneath which space itself stops making sense in any ordinary way. These are not the kinds of details that make the world feel simpler, they make it stranger. But in that strangeness, there's a kind of quiet reassurance. Because whether or not reality is simulated, it is undeniably layered. There is always more beneath the surface than what we first see. And maybe that's why this question about simulation doesn't really end up being about computers at all. It's about that feeling you get when you realise the ground under your feet isn't as simple as you thought. It's about recognising that what we call reality might only be one version of something larger, deeper, and far less familiar. If you've ever wondered whether the world is truly what it appears to be, you're not the first. Long before computers, long before we had the language to talk about simulations or code, there were people who looked at reality and felt that same pull of doubt. They didn't have screens or processors to compare it to, but they had their own ways of asking the same question. What if the world we see is only a version of something larger, something hidden? Plato, writing more than 2,000 years ago, gave us one of the earliest and clearest versions of that thought. He imagined a group of people chained inside a dark cave, their entire lives spent facing a blank wall. Behind them, a fire burned, and between the fire and the prisoners, others moved objects that cast shadows on the wall. Those shadows were all the prisoners had ever seen. For them, the shadows weren't just pictures or hints. They were reality itself. And if one of them somehow broke free and turned around, if he saw the fire and the objects casting those shapes, his first reaction wouldn't be wonder. It would be confusion, maybe even pain. That story wasn't about caves or fires or even shadows. It was about perception. Plato's point was simple. What we see is not necessarily what is. We might be mistaking a limited version of reality for the whole thing, and if we ever saw what lay beyond our narrow view, it would feel almost impossible to recognise at first. Move forward many centuries, and you find René Descartes sitting alone with a similar doubt. He looked at the world around him and realised that if he wanted to be certain of anything at all, he had to be willing to strip away everything he couldn't prove. What if all of this, he wondered, is a dream? What if every sound, every touch, every sight is an illusion? He went even further, imagining an evil demon, a being powerful enough to deceive him completely, creating an entire false reality for him to live in without ever knowing the difference. Descartes didn't mean that such a demon literally existed. He was making a point. If you can imagine a scenario where everything you experience is false, and you wouldn't know it, then you can't rely on experience alone to tell you the truth about reality. His solution was to find a single thing he couldn't doubt, his own act of thinking. "I think, therefore I am," he wrote, because even if everything else was an illusion, there was still the fact of himself, the one doing the doubting. Even so, the thought he left behind has never gone away. His demon has been replaced by different metaphors over the centuries, by dreams, by elaborate mechanical worlds, and eventually by computers, but the underlying question is the same. If you can't fully trust what you see, what can you trust? Then there's Zhuangzi, the Chinese philosopher who lived even earlier than Descartes or Plato. One night he dreamt he was a butterfly. He didn't just dream about a butterfly. In the dream, he was a butterfly, flying lightly and freely without any memory of being human at all. When he woke up, he found himself troubled by a strange question. Had he been a man dreaming of being a butterfly, or was he now a butterfly dreaming that he was a man? That simple image has lasted for more than 2,000 years. You can picture it easily. One moment you're yourself, the next you're a butterfly, and when you wake up, you're not entirely sure which version of reality was more real. That's the kind of doubt that doesn't need technology to exist. It comes from the simple fact that our experience of the world depends on the point of view we're trapped inside. Each of these early thinkers gave us a different way of seeing the same thing. Plato showed us that what we take as obvious might just be shadows. Descartes reminded us that experience alone can be fooled. Zhuangzi added the dream, the unsettling sense that even when you feel awake, there's no ultimate test that proves you aren't still dreaming. These ideas didn't fade because they were never tied to a specific moment in history. They're not outdated in the way an old scientific theory becomes outdated. They live in the same place the simulation question lives, at the point where the edges of what we can know meet the vastness of what we can't. And even if they didn't use the word simulation, you can hear the echo of it in their words. The cave is a closed system with its own rules. The demon controls every perception. The dream traps you in a reality you can't distinguish from waking life. None of these are about computers, but they're about the same core problem. If you're inside a system that defines all of your experience, how would you ever step outside of it to see the truth? When you look at it that way, modern discussions about simulated worlds don't sound as modern as they first seem. They're just the newest version of a much older conversation. The difference is that now, instead of shadows or dreams, we talk about code. We imagine that instead of an evil demon, there could be something like an architect or a programmer, not necessarily human, but intelligent enough to build a reality from the ground up. And in a strange way, that shift makes the question feel even sharper. Because unlike demons or dreams, simulations are no longer entirely hypothetical. We already make small ones ourselves. We build virtual worlds for games. We create models of weather systems and galaxies. We write programs that simulate evolution or the behavior of atoms. None of them are anywhere near the scale of an entire universe, but they prove the principle. It's possible to create a world that feels real from the inside, at least to whatever is living there. If philosophers from centuries ago had been told that one day we'd build such things, they might have nodded in recognition, not because they would have understood the technology, but because they would have recognized the shape of the question. They'd already been circling it for generations. What all of this shows us is that the thought has been here for as long as we've been able to wonder about our own existence. It doesn't need computers to survive. It doesn't need proof to keep coming back. It's part of the way human beings respond when they stare too long into the mystery of the world and realize how thin the line is between what's known and what's only assumed. And that's why, before we even begin talking about physics or digital theories or scientific experiments, it's worth stopping here for a moment. Because this is where the roots of the question are, in the cave, in the demon, in the butterfly's wings. But we're not staying here. We're only passing through on our way forward. The philosophers gave us the starting point, but the world didn't stop with them. Over time, new tools, new discoveries, and new ways of thinking have changed the way we look at the same question. And the next step is to see how those tools brought us from shadows and dreams to the first real cracks that made people wonder if our world has limits. Limits that might one day be tested. Even if the idea of living in a simulation began as philosophy, it's the little moments in everyday life that keep the thought alive. Not the kind of moments you can measure in a lab, but the ones that make you stop just for a second and wonder if something is slightly off. These are the small cracks people sometimes call glitches, not because they prove anything, but because that word fits the feeling. A brief pause in the rhythm of the world, a sense that the system slipped for just a heartbeat before it smoothed itself out again. You've probably felt it before. A flash of déjà vu so sharp and familiar that you'd swear you've lived the exact moment already. The way someone speaks, the angle of the light in the room, even the sound of your own voice as you answer. It all lands exactly as it did in a memory you can't quite place. Most of the time you brush it off, because what else can you do? The world doesn't stop. You keep moving. But for those few seconds, it's as if you've been shown a line of code hidden in the corner of the screen. Science has explanations for this, of course. Déjà vu might be nothing more than your brain misfiring, cross-wiring a present moment with the faint echo of something similar in the past. But the explanation doesn't erase the feeling, and the feeling is what people keep coming back to. It's what gives the word glitch its quiet power, not proof, not certainty, just that strange, unsettling fit between what you see and what you can't explain. It's not only déjà vu. Think about coincidences so sharp they almost feel deliberate. You think of someone you haven't talked to in years, and a few seconds later, their name lights up your phone. You hum a song at random, then hear it playing in a cafe you've never been to before. These things can be explained too. Our minds are pattern-seeking machines. Out of all the thousands of random events happening around you every day, a few are bound to line up in ways that feel uncanny. But in the moment, when it happens, you can't help but feel like you've brushed against the edge of something larger. And then there are the stranger stories people tell. Moments where time seems to skip, objects that appear where they shouldn't be, encounters that feel too precise, as if they've been slotted into your life at exactly the right or wrong time. Most of these have simple answers if you look hard enough. Memory is slippery, perception is imperfect, but the reason people share them isn't because they've been solved. It's because they leave behind that same quiet question. What if that wasn't an accident? When you step back, these little glitches start to look less like evidence and more like reminders. They show us how fragile our sense of normalcy really is. You live most of your life on solid ground, but it only takes one strange moment to make you glance down and wonder what's holding that ground up. This is part of why the simulation question doesn't go away. If the world were seamless, if nothing ever stood out, we might not think about it so often. But reality has a way of slipping just enough to let those thoughts in. And once they're in, they don't leave. Of course, it's important to keep perspective. No scientist would look at déjà vu or coincidence and call it proof of anything cosmic. Those moments are too small, too personal, too tangled in how our minds work. But in another sense, they matter precisely because they are small and personal. They're the entry points. They're how the question first sneaks into an ordinary day, and once it's there, it tends to grow. You start thinking not just about the glitch you felt, but about the rules underneath everything. If something could break, or at least feel like it's breaking, what does that say about the system itself? Does it mean there's a system at all? Or does it simply mean that our understanding of it is thin in places, like a piece of fabric stretched too far? This is where the simulation idea finds its foothold. Not in data, not in formal arguments, but in the moments that make you hesitate. The seconds where you feel like you're looking at the world from just a fraction of a step outside it. You don't have to stay there for long. The ordinary world always comes back, but those seconds are enough to leave a mark. And maybe that's the real point. Whether they're glitches or just quirks of the mind, they make you pay attention. They pull you out of the flow you live in every day and make you look at reality from an angle you usually ignore. Even if nothing's wrong, even if everything is exactly what it seems, you've been reminded that it's still worth asking what lies beneath it all. That's why we're going to keep following that thread. Because once you've noticed the surface flicker, it's natural to wonder about the structure holding it together. And that structure, the deep framework of reality, is where this question begins to shift from philosophy to science, from shadows and dreams to math and physics. If you strip the world down as far as you can go, past the tables and chairs, past the atoms and particles, past even the forces that hold it all together, what's left starts to look less like matter and more like information. That's not a poetic metaphor. It's a serious idea that has been gaining ground among scientists and thinkers who study the most fundamental nature of reality. At first, it sounds strange. You expect the universe to be built out of things, physical objects, pieces that stack together to form bigger pieces like bricks making a wall. But when you dig deep enough, that picture falls apart. An atom is not a tiny marble, it's mostly empty space. Its particles are not little balls of matter in the way we imagine them. They are events, they are interactions. They are the answers to questions about what happens when you measure something. And those answers, at their core, are bits of information. This is what some physicists mean when they talk about the universe as if it were digital at its base. Not in the sense of screens or electronics, but in the sense that everything we see might be described by fundamental yes or no states, the way a computer runs on ones and zeros. In this view, reality isn't made of matter first and information second. Reality is information, and matter is simply what information looks like when you experience it from the inside. Even if that sounds abstract, you've seen hints of it already, whether you realized it or not. Every law of physics we know can be written down as a kind of equation. Those equations aren't just descriptions, they're instructions. They don't merely say how the universe happens to behave, they say how it must behave, everywhere and at every scale. And if those instructions are precise enough, it becomes hard not to notice how similar they look to the way a program operates. Think about light. It moves at one speed, always, no exceptions. It doesn't matter how fast you're going or where you are, that rule holds. That's not just a convenient coincidence, it's a fixed parameter of the universe. The same is true for gravity, for the charge of an electron, for every constant that sits in the background of reality, unchanging. These are the rules of the system, and without them the world would come apart. Now imagine those rules as lines of code. You don't have to picture an actual computer running it all. You just need to think about the similarity. A program is a set of instructions. Change those instructions, and the program behaves differently. Change the laws of physics, even slightly, and the universe would look nothing like the one we know. This is where the simulation argument picks up its strength. If the universe really is built out of information, if everything we see can be reduced to patterns in data, then asking whether it's running on something isn't such a wild leap. In fact, some researchers argue that the informational nature of the universe is exactly what we would expect to see if it was simulated. Consider the Planck scale, the smallest unit of length that has any physical meaning. Below that, space itself stops behaving like space. It's as if the universe has a resolution limit, a smallest pixel size beneath which the very idea of smaller doesn't apply. You can keep dividing an image on a screen down to the level of individual pixels, but you can't split a pixel in half and still get more detail. In the same way, physics suggests there may be a fundamental grain to reality. If true, that's remarkable, because it means the universe is not infinitely smooth. It means that just like digital information, it's built out of discrete units. It's not proof of anything, but it fits the picture. A world that behaves more like data than like an unbroken physical substance, and it's not only space. Time too may come in these tiny indivisible steps. What we experience as a steady, continuous flow could be a sequence of tiny ticks, each one the smallest possible unit of duration. If you could zoom in far enough, you wouldn't find a river of time, you'd find frames, flipping one after the other faster than anything we could ever perceive. When you put this all together, a pattern starts to form. A universe with limits to its resolution. A universe whose behavior can be described in precise mathematical language. A universe where matter itself is secondary to the information that defines it. From there, the question follows naturally. If reality looks like information, does that mean it is information? And if it is, then is it really such a stretch to imagine that the thing we call the universe might be the output of something deeper, something that processes that information the way a program processes code? It's important to be clear, none of this proves that we live in a simulation, but it shows why the idea has moved from the edges of philosophy into the conversations of serious science. If information is fundamental, then in some sense what we call reality is already a kind of computation. Whether or not there's a computer in any literal sense doesn't change the fact that the world behaves in a way that feels strangely familiar to those who study both physics and information theory. You can even see this idea at work in quantum mechanics, where the smallest pieces of reality don't seem to have definite properties until they're measured. It's as if the universe only fills in the details when the information is needed, the way a simulation renders parts of a virtual world only when a player turns to look at them. None of this needs to be frightening. It doesn't take away from the reality you experience. The chair you're sitting on still holds you up. The air you breathe still fills your lungs. But beneath it all, there's this quiet possibility that what you're really living in is something more structured than it looks. An ocean of information, ordered and exact, waiting to be read. And that's where this question begins to shift once more. If the universe is information, then maybe mathematics isn't just a tool we use to describe it. Maybe mathematics is the language the universe is written in, and if that's true, it might tell us something extraordinary about why the world feels so strangely comprehensible, as if it's been designed to be understood. If information is the foundation of reality, then mathematics is the language it speaks. Not just the language we use to describe it, but possibly the language it's written in. That might sound like a subtle difference, but it changes everything. Because if mathematics is more than a tool, if it's not something we invented but something we discovered, then it's not simply sitting in our minds, it's out there, woven into the structure of the world itself. Look around and you'll see it. The universe is full of patterns that follow mathematical rules with an almost eerie precision. Planets orbit their stars according to the equations of gravity. Light bends and spreads exactly as described by the mathematics of electromagnetism. Even the tiny particles that make up your body follow probabilities that can be written down so cleanly that they've been tested to more than a dozen decimal places without failing once. If the universe were messy, random, or chaotic in its deepest workings, you might expect mathematics to only approximate it, to get close, but never quite fit. But that isn't what happens. Instead, math fits reality so perfectly that it raises a question many scientists quietly wonder about. Why should it be this way? Why should something we write on paper match the behavior of galaxies, black holes, and particles smaller than atoms? It's tempting to say it's just because we made mathematics to match the world, but then you look at cases where math predicts things long before anyone observes them. The existence of Neptune, for example, was discovered not through a telescope but through math. Astronomers saw the way Uranus was moving and realized there must be another planet tugging on it. They calculated where it had to be, pointed their telescopes, and there it was. The same thing happened with the Higgs boson. The mathematics of particle physics demanded it. Decades later, the experiments confirmed it. This is the strange, quiet power of math. It doesn't just describe the world, it sometimes seems to know the world better than we do. And that's why, for some people, it feels less like a human invention and more like the underlying script of reality. Now, think about what that means for the simulation question. A program runs on code. Every behavior in that program is defined by rules. If you were inside such a program, those rules would be invisible most of the time. You wouldn't see the code directly. You'd only see the world it generates. But if you studied that world carefully enough, you might start to notice that it follows exact, unchanging laws. You might call those laws physics, and you might write them down as mathematics. In that sense, the math we find in the universe could be thought of as a kind of signature, not proof, not evidence in the strict sense, but a clue that we're living in a world that is fundamentally rule-based, a world that behaves exactly the way you would expect if it were built, layer by layer, on an unbreakable framework of logic. And mathematics doesn't just describe the big and the obvious. It also governs the hidden structures we don't even notice most of the time. Consider the Fibonacci sequence, a simple pattern of numbers, each one the sum of the two before it. You see it in sunflowers, in the spirals of shells, in the branching of trees. No one programmed those plants or shells to follow the sequence. They simply do. Because the mathematics isn't something external. It's built into the way the world organizes itself. This is where the idea of the universe as something written in code starts to feel less like science fiction and more like a way of looking at what's already here. A simulated world would have rules, and those rules would have to be elegant enough to work everywhere. They'd have to explain the behavior of galaxies and atoms alike. They'd have to be universal. And that's exactly what mathematics looks like. Even at the smallest scale, math never fails. Quantum mechanics, strange as it is, runs on equations that predict the behavior of particles with uncanny precision. Einstein's theory of relativity, tested over and over again for more than a century, continues to match the way the universe bends and shifts under the pull of gravity. Every time we push deeper, The mathematics is already there, waiting for us to uncover it. If you pause and think about it, that's a strange thing. It's one thing for a set of rules to work most of the time. It's another for them to work perfectly, across scales so vast and different that they defy ordinary imagination. That kind of consistency doesn't just look like coincidence, it looks like structure. Of course, there's another way to see it. Some argue that math feels this way not because the universe is programmed, but because math is the only language capable of describing any universe at all. If you lived in a reality that wasn't structured, you wouldn't be here to ask questions in the first place. Life, thought, and understanding require order, and if order is the only reason we can exist, then it's no wonder the world looks ordered to us. That's the kind of argument that pushes this question back and forth, not toward answers, but toward deeper layers of wondering. Maybe the universe is mathematical because it must be. Maybe it's mathematical because it was written that way. Either way, you're left with the same strange fact. Math is everywhere, and it works with a precision that feels almost unnatural in its reliability. And that brings us back to where this path has been leading. If mathematics is the structure, then the universe is not just matter moving in space. It's a system of rules playing out in real time. And if that's true, then we're not simply living in a physical world, we're living inside a framework that behaves exactly the way a simulation would, even if it isn't one. When you shrink reality down to its smallest scale, the familiar rules start to break apart. The solid ground you thought you were standing on gives way to something that feels almost unrecognizable. This is the world of quantum mechanics, where particles behave less like tiny marbles and more like flickers of possibility, where certainty gives way to probability, and where even the act of looking can change what you see. If you are expecting the universe to feel simpler at its foundation, this is where that expectation falls apart. Instead of clean, predictable movements, you find particles that can exist in more than one place at once until you measure them. You find electrons that don't orbit their atoms in neat little paths, but instead smear themselves into strange probabilistic clouds. You find pairs of particles that remain mysteriously linked, so that a change to one instantly affects the other, no matter how far apart they are. For over a century, this has been one of the most unsettling parts of physics. Albert Einstein himself called it spooky action at a distance, because even he couldn't accept how strange it sounded. But experiments have confirmed it, over and over again. No matter how much it contradicts our everyday sense of reality, this is the way the universe behaves at its smallest scale. Now think about what this means for the simulation question. In a world built from straightforward physical stuff, you'd expect certainty. You'd expect everything to have a clear, well-defined state at all times. But that's not what quantum mechanics gives us. Instead, it looks more like a system that only resolves itself when it has to. A particle's position is just a range of probabilities until it's observed. It's as if the universe is holding multiple possibilities in suspension and only committing to one when there's a reason to. This has led some people to make an interesting comparison. In a computer simulation, you don't render every single detail of a world at once. You only render what's needed when it's needed. The rest stays in the background, waiting until the player turns their head or moves into a new area. It's a way of saving processing power, of not wasting resources on things that no one is looking at. Quantum mechanics, in its own way, seems to work like that. It's not proof of anything, but the resemblance is striking enough that even serious scientists sometimes wonder if there's a connection. Maybe the universe doesn't need to fill in every detail until reality calls for it. Maybe it operates on rules that are deeper than what we experience directly, rules that act only when the information has to be resolved. Then there's quantum entanglement, where two particles become linked so tightly that no matter how far apart they are, they behave as if they're still one system. Change one, and the other changes instantly, faster than any signal could travel between them. That's not just counterintuitive, it's as if the universe itself is bypassing the normal rules of space and time, because at that level, space and time don't seem to matter in quite the same way. You could think of entanglement as a kind of hidden wiring between parts of reality, a reminder that what we see as separate might be connected in ways we can't directly perceive. In a simulation, everything is tied back to the same underlying system, no matter how far apart the objects on the screen appear. The distance is just part of the display. Underneath it's all connected. And then there's the simple, unavoidable fact that quantum mechanics is not just strange, it's precise. The equations that describe this behavior work with absurd accuracy. They predict the results of experiments to many decimal places without fail. So even though this world of particles and probabilities feels alien, it's not chaos. It's structured. It's exact. It's a rule set, even if the rules aren't what we expected them to be. This is why the quantum world is such an important piece of this puzzle. It doesn't just make reality look strange, it makes reality look like something that operates on a kind of hidden logic, one that is abstract, mathematical, and, if you squint, almost computational. And if you follow that thought, it begins to change the way you see the ordinary world. The chair you're sitting on, the floor beneath your feet, even your own hands are made of particles that obey these bizarre rules. You don't see that weirdness in your daily life because at larger scales, all those probabilities smooth out into the solid, predictable world you recognize. But beneath it, the strangeness is always there, humming quietly, never breaking the laws it's built on. That's what makes this part of the story so fascinating. The quantum world isn't a separate place. It's not somewhere else. It's the foundation of everything, and it behaves in a way that feels far closer to an underlying program than to the intuitive idea of physical matter we all grow up with. And from here, the question grows sharper. If reality is built on these deep, rule-driven systems, if everything from the behavior of a light to the linking of entangled particles fits into a perfectly consistent framework, then who or what wrote those rules? Or are they simply there, uncaused and unexplained, the way a program can exist without anyone ever seeing the code that runs it? We're not answering that yet. We're only stepping deeper into it. Because after looking at the smallest pieces of reality, the next step is to think about the larger picture, not just the rules themselves, but the possibility of something, or someone, behind them. If the universe works like a system of rules, it's natural to wonder whether there might be a mind behind those rules, not in the sense of a figure from myth or a single familiar image of a creator, but in a broader, stranger way. If we are living in a simulation, then someone, or something, must have built it. And if it was built, it must have been built for a reason. This doesn't mean imagining a person sitting at a desk typing commands into a machine. It might not look anything like the way we build software. In fact, it probably wouldn't. But the thought experiment asks you to consider it anyway. If this world is programmed, who are the programmers? Some people imagine advanced civilizations being so far beyond us that their technology would look like magic. They might live in a base reality, a world as far removed from ours as ours is from the simulated characters in a video game. For them, building a universe like this might be as ordinary as running a simulation on a computer as for us. It could be a scientific experiment, a way of studying how universes form and evolve. Maybe even a kind of entertainment, something they observe the way we watch a film, except the story is written in galaxies and stars instead of images on a screen. Others take the idea further and imagine something less personal. Instead of a civilization of programmers, they think of an intelligence so vast and alien that calling it a being doesn't quite fit. Maybe it's an artificial mind, the descendant of some ancient technology, running on a scale we can't comprehend. Maybe it doesn't even think the way we do. Maybe it simply runs, an endless process, creating realities the way a tree creates leaves, automatically, without ever needing to explain itself. And then there are those who suggest that the question might not have an answer we'd recognize at all. If this is a simulation, its creators might not live in anything we'd call a world. They might not experience time or space or thought in any way that's meaningful to us. To them, our universe could be nothing more than a structure inside another structure, one layer in a stack of realities that has no clear beginning. It's easy to get lost in that. But part of what makes this line of thinking so powerful is that it isn't really about proving anything. It's about seeing the scale of the possibilities. If the universe was made, then its makers might be beyond our understanding. But that doesn't stop us from asking. And in a way, asking is the point. Of course, not everyone finds this idea comforting. Some look at it and feel small, imagining a reality where everything they know is just part of a program running in some unimaginable system. But there's another way to see it. If there is something, someone, behind this universe, then it means none of this is random. It means there's structure not just in the laws of physics, but in the fact that those laws exist at all. It also raises a different question, one that's just as unsettling as it is fascinating. If there are architects, could they ever reveal themselves? Or would they remain hidden forever, letting the simulation run without interference? If you were building a world as detailed as this one, would you step inside it, or would you stay outside watching? Some thinkers even turn the question around. What if we're the ones meant to find them? Maybe the universe is full of clues, but they're not the kind of clues you can trip over in your daily life. They'd be buried in the deepest patterns of mathematics, hidden in the edges of physics, waiting for someone to dig deep enough to see them. This is where the simulation idea stops feeling like just a theory and starts to feel like an invitation. Because even if there are no architects, even if there is no one outside the system watching us, the act of looking changes how we see the world. We stop taking it for granted. We start noticing the precision of it, the improbability of it, the way it all fits together as if it were designed to be discovered. Whether or not anyone is out there doesn't change the fact that the rules are here. They work. They hold everything together. And if there are architects, maybe that's the only message we were ever meant to find, that we're living in something vast, ordered and capable of being understood, at least in part, by minds like ours. This is where the thought turns again, not outward but inward. Because if there are creators, if there are architects, then what does that make us? Are we simply observers, or are we participants in a design we can't fully see? If it's possible that our universe is a simulation, then a stranger possibility follows almost immediately. What if this is not the only one? What if simulations can be stacked, one inside another, like mirrors facing each other in an endless corridor, each reflection containing another? Is not just a philosophical game. Think about how we use technology today. We already build simulated worlds, digital environments for science, for entertainment, for training. Those simulations aren't nearly as detailed as reality, but they don't need to be. They still create spaces where entire systems run on rules, where people and programs interact, where events unfold as if they were happening for real. Now imagine a civilization far more advanced than ours. If they could build a universe as rich and detailed as this one, there's no reason they couldn't also build smaller ones inside it. And if the beings inside those simulated worlds reached the point of building their own simulations, the stack would keep growing. A chain of realities, each one nested within another, each one believing it's the base layer until it looks a little too closely. This is where the concept starts to bend your sense of scale. Because if such a hierarchy exists, the odds of being in the one real original reality gets smaller and smaller. Out of 1,000 layers, why would we assume we're at the top? If anything, it would be far more likely that we're somewhere in the middle, running our lives inside a world built on another world, unaware of the many others above or below it. And if that sounds unsettling, it's worth pausing to think about how little it would change. Even if there are layers upon layers, you still live here in this one. Your thoughts, your memories, the ground beneath your feet, all of it is as real to you as it has ever been. If there are deeper levels, they don't erase this one. They simply frame it in a larger context, the way a single page belongs to a book you've only just begun to open. Some scientists have even speculated about what would happen if two simulated realities interacted, or if a world like ours ever reached the point of building its own equally convincing universe. Would it be any different from what we already see? Or would it all blend together, layer after layer, each one as convincing to the minds inside it as the last? The most striking part of this idea isn't its complexity, it's how natural it feels once you consider it. We already see recursion everywhere in nature. Trees branch into smaller branches, rivers split into smaller streams, cells divide into smaller structures. A nested reality would simply be one more version of that same pattern, repeated on a cosmic scale. And in some ways, it even answers a quiet question about why our universe is so precisely tuned. If this were the only reality, it might feel almost impossibly fortunate that everything works as well as it does, that the rules are so exact they allow life to exist at all. But in a chain of simulated worlds, precision would be the point. Each layer would be built with rules that make sense, rules that allow complexity to grow, rules stable enough for minds to emerge and wonder about the nature of their own reality. None of this proves anything, of course. We can't peer beyond the walls of this world to see what's outside it, if anything is. But thinking about these nested realities shifts your perspective. It turns the question from, is this the only one, into, why would it be? And that's enough to make you see even the ordinary world a little differently, as though the air around you might be part of a much larger structure, one that stretches far beyond anything you can see. If that's true, then what we call reality may not be an endpoint at all. It may just be one level in a ladder that climbs higher than we can imagine, and perhaps even lower, into simulations running within simulations, each one as convinced of its own solidity as we are of ours. And that brings us to a bigger question, one that isn't about layers or levels, but about why they might exist at all. If there are architects, and if they built not one reality but many, what would be the purpose? Why create a structure this vast, this intricate, and leave it running? For a long time, the question of whether reality might be an illusion or a simulation lived mostly in philosophy, in quiet conversations and thought experiments that didn't claim to have answers. But in recent years, something has changed. The conversation has shifted from abstract speculation to something scientists are willing to examine, not because they've found proof, but because the structure of the universe keeps inviting the question back. It started with simple curiosity. Physicists, computer scientists, and even philosophers working with data began to notice the same patterns. They didn't just look at the elegance of mathematics or the strangeness of quantum mechanics. They looked at the fact that reality, for all its complexity, behaves like a system with laws, boundaries, and limits, things you'd expect if it were built, even if we don't yet know by whom or by what. One of the first to put it forward in a serious way was Nick Bostrom, a philosopher who proposed the simulation hypothesis in a form that science could discuss. He didn't argue that we are in a simulation. Instead, he laid out a simple trilemma. Either civilizations never survive long enough to create simulated universes, or they have no interest in doing so, or they create so many that the odds of being in the single real world are vanishingly small. That last option is the one that captured people's attention, because if a civilization could build a simulated universe as convincing as this one, why would they stop at one? Why wouldn't they build thousands or millions? And if they did, what would that mean for us? Some scientists looked at this and dismissed it as untestable, but others saw an opportunity. They began asking, if this is a simulation, what would it leave behind? Could there be evidence hidden in the rules of physics that points to an underlying framework? One proposal is that if the universe was simulated, there might be limits to its resolution, an ultimate pixel size of reality. That smallest unit, the Planck length, already exists in physics, but some researchers have suggested that future experiments might be able to detect subtle effects. like the faint graininess you'd expect if space itself were quantized, like pixels on a screen. Others have gone further, suggesting that the cosmic rays streaming through space could hold clues. If the universe were running on a kind of underlying grid or lattice, particles moving at extreme energies might behave differently, leaving behind tiny signs that the fabric of space isn't perfectly smooth. No one has found such evidence yet, but the fact that scientists are even asking these questions marks a shift. It means the idea has stepped out of the purely philosophical realm and into one where experiments, however ambitious, might someday weigh in. And yet, for all the attempts to measure it, there's another reason this idea resonates in science. It explains something that has always been hard to explain. The universe is not just functional, it is strangely understandable. Its laws are written in a way that can be decoded. We have no guarantee it should be that way, and yet it is. The simulation hypothesis, even if it's only a story for now, offers one way of looking at that mystery. That doesn't mean everyone agrees. Many scientists would rather treat the universe as it appears, without reaching for hidden layers. But even among skeptics, there's a quiet acknowledgement that these questions about information, about the mathematical nature of reality, about its possible boundaries are not going away. If anything, they're becoming harder to ignore. And perhaps that's the real reason science has joined the dream. Not because it wants to prove the hypothesis true or false, but because the act of examining it pushes us to learn more about the universe itself. Every time someone asks whether the world is simulated, they end up looking at the most fundamental questions in physics. What is space? What is time? What is information? What does it mean for something to exist? These are not questions that end quickly. They lead into deeper and deeper territory, and each step further in changes how we see the step behind it. Even if no one ever finds evidence of a simulation, the search itself forces us to see the universe differently, not just as a place we live in, but as a structure we're still only beginning to understand. And that's why the next turn in this path matters. Because after all of this curiosity and speculation, we're left with a simple fact. For now, there's no definitive proof. No one can point to a single experiment that shows we're living in a simulation, and that absence is just as important as anything else, because it's what keeps this question balanced between possibility and mystery, with just enough room to keep wondering. For all the theories, all the thought experiments, and all the careful arguments, one thing remains. There is no proof. Not yet. No single piece of evidence that forces us to accept that we're living in a simulation. And that absence matters, because it's what keeps this question in the space between science and speculation, between what we can measure and what we can only imagine. If the universe were simulated, what would we expect to see? Some researchers suggest we might find subtle glitches in the laws of physics, tiny irregularities that would hint at an underlying framework. Others have proposed that there could be measurable limits to reality, signs that the universe is built from discrete pieces like pixels on a screen. And yet every time we push the limits of our technology and look closer, we find nothing but more precision. The rules hold, the equations work, no seams appear. In fact, the very success of science is what makes this question harder to answer. The more we learn, the more consistent the universe seems. We build particle accelerators to smash matter apart, and instead of breaking the illusion, we find new layers of order. We measure the expansion of the cosmos, and it follows patterns that can be written down and predicted. The deeper we go, the less it looks like a system with cracks, and the more it looks like one that has been built with impossible care. But that in itself is what keeps the question alive. If a simulation were perfect, if it were seamless, how could you ever prove it wasn't real? A well-constructed simulation wouldn't leave behind obvious flaws. It wouldn't give you visible edges to grab onto. It would be complete enough that the only thing left to question would be the fact that it works so well. And that's exactly where we are. No errors, no missing pieces, just a world that runs with a kind of precision that makes you wonder how deep it goes. Even the best-known tests for the simulation hypothesis are more like thought experiments than actual experiments. Nick Bostrom's statistical argument isn't proof, it's probability. The proposals about detecting a hidden grid in space remain hypothetical. The search for quantum signatures that might point to underlying computation is still in its infancy, and none of it has produced anything definitive. For now, what we're left with is a strange balance. The simulation hypothesis is neither confirmed nor disproven. It's not science fiction, but it's not established science either. It sits in a middle space, where the absence of evidence doesn't close the door, but it doesn't open it either. And maybe that's exactly why it holds so much power over the imagination. Because the lack of proof means it can't be dismissed, but it also means it can't be solved. It lives in the quiet gap between what we know and what we suspect, a reminder that even our most confident understanding of reality might still be resting on something deeper. Some scientists argue that this lack of evidence is a good thing. It keeps us focused on what we can actually study instead of chasing ideas that may never be testable. But others see value in the question even without proof, because it forces us to sharpen our view of the world. Even if we never find a sign that we're simulated, the search pushes us to look more closely at the structure of reality itself. That's what makes this question unusual. It's not about solving it. It's about what it does to the way we see. It takes the familiar and makes it unfamiliar again. It turns every constant and every equation into a clue, not because they prove anything, but because they make you wonder why they exist at all. And that's why the absence of evidence isn't the end of this story. It's the beginning of the next turn. Because if there are no glitches to find and no edges to touch, then the question shifts away from the outside world and turns inward. If you can't break the illusion from the outside, maybe the only way forward is to look at the part of reality that doesn't just follow the rules, but experiences them. The part that thinks, feels, and wonders. The part that's listening to this right now. If there is one part of reality that refuses to fit neatly into equations, it's consciousness. You can measure particles, you can describe the laws of physics, you can even reduce matter to pure information. But the experience of being, of seeing, feeling, and knowing you exist, sits apart from all of it. And for some, that makes it the most important piece of this question. Because if the universe is a simulation, then what exactly is consciousness? Is it part of the simulation, a process running inside the rules of the system? Or is it something separate, something that slips through those rules and points to something deeper than the world we see? Scientists have tried to explain it for decades. Neuroscience can trace the patterns of the brain, mapping which regions activate when we think, remember, or dream. But none of that explains why any of it feels like anything. A simulation can move data around endlessly, but feeling, the raw sense of I am, is different. No equation yet explains why there is a point of view, or why the universe has anything in it that experiences itself from the inside. And that is where this question takes a turn. If consciousness is fundamental, if it can't be reduced to anything simpler, then maybe it's not just part of the program. Maybe it's the one thing in this whole system that doesn't fit neatly into the frame of a simulated world. Some philosophers have even suggested that if there is something outside the simulation, something running it, consciousness might be the part of us that touches it. Of course, there's another way to see it. If this world is simulated, then consciousness itself might simply be the product of computation. Not a separate force, not an exception to the rules, but the ultimate proof of what those rules can create. Just as a program can generate images or sound, maybe it can generate awareness. Not as a trick, but as an inevitable result of complexity. Both views run into the same wall. We don't yet know what consciousness really is, and until we do, it remains a gap in the map of reality, a gap big enough to keep the simulation question alive. Because if you can't explain why you are aware, then you can't rule out the possibility that awareness itself is either the key to the simulation or the one thing it can't contain. And that's where things get even stranger. Some physicists and philosophers have started to wonder if consciousness isn't just an accident of biology, but something woven into the structure of reality itself. If that's true, then it might be the one thing that connects all layers of existence, whether simulated or not. A kind of bridge between whatever is running the world and the world that's being run. This isn't something you can test the way you can test the speed of light or the orbit of a planet. But it's not something you can easily dismiss either, because no matter how much you analyze the universe, it always comes back to this simple fact. There is something here that is aware of it, something that can sit quietly and wonder what it's made of. And if we are in a simulation, maybe that awareness is the point. Maybe the universe was built not just to run, but to be observed, to be experienced from the inside. Maybe the act of looking, of thinking, of asking these questions is not a side effect of the program, but one of its most important features. That would explain why the world is understandable, why mathematics fits, why the laws of physics form a perfect, unbroken web that seems designed to be explored. If the universe is a simulation, consciousness might not be an accident of that design. It might be the reason for it. But whether that's true or not, one thing is certain. Consciousness is the one part of reality that refuses to be ignored. You can look at atoms and galaxies and write down equations, but none of it matters without something there to see it. And that's why, for many, this question about whether we are living in a simulation always circles back to the same point. Not out there, in distant stars or hidden grids of space, but in here, in the quiet fact of being aware. If you keep zooming in on the universe smaller and smaller, past atoms, past the particles inside them, down to the point where space and time themselves begin to lose their usual meaning, you eventually reach a scale that physics can't go beyond. This is the Planck length. It's not just small, it's the smallest distance that can exist in any meaningful sense. Below it, the very idea of smaller stops working. To put it in perspective, a single atom is unimaginably tiny. The Planck length is to an atom what an atom is to an entire galaxy. It's so far beyond anything we could ever touch or see that it almost feels abstract, like a number that exists only on paper. And yet, according to the equations of modern physics, this scale isn't just a mathematical curiosity, it's real. It's the boundary where space itself seems to have a kind of resolution limit, as though reality is made of pixels too small for us to see. This is one of the reasons some scientists draw a connection between physics and computation. In a digital world, you can only zoom in so far before you hit the pixel grid. There is no infinite smoothness, no endless detail. You reach the fundamental building blocks, the smallest unit of the display, and everything beyond that simply doesn't exist. The Planck length is the universe's version of that boundary. You can divide and divide and divide, but at that scale, there is no more dividing left to do. And it isn't just space. Time too may come in these smallest possible steps, what some call the Planck time. Instead of a continuous river flowing without interruption, time could be more like a series of frames in a film, flashing so fast that they blur into a smooth experience. You don't notice the individual frames because the rate is far beyond anything you can perceive. But underneath, they could still be there, the hidden ticks of the universe's clock. If reality really does have this kind of discrete structure, it raises a remarkable possibility. Because a world with the smallest unit of space and time is not an infinitely smooth machine. It's a finite system, built out of fundamental steps, like the smallest pieces of data in a program. That doesn't prove we live in a simulation, but it fits the pattern of one. It suggests that there is a level of resolution baked into the universe itself, a level where everything below simply vanishes. And this is where things start to connect. The Planck length, the precision of mathematics, the strangeness of quantum mechanics, they all point in the same direction. Reality doesn't just run. It runs on rules, and those rules seem to stop at a very specific limit. If we ever reach that limit in our experiments, it might feel less like peering into infinity and more like pressing your face against the glass wall of whatever this world is built from. For now, though, we can't reach it directly. Our tools, as advanced as they are, still work far above that scale. We can only infer what's there by looking at the way the universe behaves at slightly larger distances, like trying to guess the texture of a painting by standing just a little too far away to see the brush strokes. But even from that distance, the hints are there. Some researchers even think that the universe itself might be built on a kind of grid or network at the Planck scale. Not a literal grid you could see, but a mathematical one. A framework that defines where information can be stored and how it moves. If that's true, then every particle, every force, every flicker of energy would be part of that underlying structure. Imagine looking at a screen from far enough away that the pixels blur together into a perfect image. You don't see the grid, but it's there, hidden in the way the image holds itself together. That might be what we're living in. A reality so seamless at our level that it feels infinite, but built on the tiniest, most indivisible pieces imaginable. And if there's a smaller scale, it also means there's a limit to how much detail the universe contains. You can't zoom in forever. You can't divide things endlessly. There's a flaw, and if there's a flaw, then there might also be a deeper structure that defines it. That's why some scientists argue that the Planck length could be the universe's fingerprint. Maybe it's just a fundamental property of nature, or maybe it's the place where the illusion, if there is one, becomes unavoidably clear. We don't know which it is yet, but the fact that the question even exists is what makes it so powerful. Because once you reach this point, you can't help but wonder, if the universe has pixels, what picture are they painting? And if someone, or something, built that picture, what was it trying to create? Those are the kinds of questions that don't have quick answers. They're not meant to. They're what comes next, once you've followed this path all the way down to the smallest pieces of reality, and then look back up at the world as a whole. And when you do, the next thing to ask isn't about the pixels themselves. It's about why the picture they form is as beautiful as it is. If the universe is a simulation, it's hard not to wonder why it exists. If there is some kind of system running behind everything we see, then what is it for? Is it a test, an experiment, a story, or something else entirely? And if there is a goal, what role do we play in it? One of the most common ideas is that this universe could be a kind of sandbox, a place built to explore. If you were a civilization capable of creating worlds as rich and detailed as this one, why wouldn't you? You might build them to study how life emerges, how civilizations grow, or how intelligence adapts to different kinds of environments. In that case, our world wouldn't have a single narrative goal. It would simply run, branching out into countless paths, each one unfolding according to the rules. Others imagine something more deliberate. They picture a simulation designed to teach, or to test. Maybe the point isn't just for the universe to run, but for the beings inside it to reach certain milestones. Maybe the laws of nature, the complexity of life, and even the questions we ask are part of a process that nudges us towards something. Greater understanding, deeper awareness, or simply the ability to see the framework we're living in. There's also the possibility that there is no single purpose at all, at least not one we would recognize. Consider how we build our own simulations. Some of them are scientific, but others exist purely for play. We make virtual worlds not because they have meaning, but because they can. Because creating them is interesting. Because watching them evolve is satisfying. If a civilization were powerful enough to simulate an entire universe, it might not need a profound reason to do so. Curiosity alone could be enough. But even if there is no grand objective, that doesn't mean our lives are meaningless. A game, after all, is still worth playing even if it isn't about winning. You can spend hours wandering in an open-world simulation, not chasing any final goal, and still feel completely absorbed by the experience. In the same way, Even if our universe isn't aiming toward a single outcome, it's still a place where experience happens, where every thought, every moment, every choice is real to the one living it. That, perhaps, is the most grounding way to look at it, because whether or not there's a goal, we're here. And the fact that we can ask these questions, the fact that we can look up at the sky and wonder about the machinery behind it, might be the closest thing to an answer we'll ever need. If there is a purpose, maybe it's as simple as this: to be able to see the world and ask what it is. Some thinkers have even suggested that if this is a simulation, maybe the goal isn't about us reaching some external destination. Maybe the purpose is built into the act of becoming aware of the system itself. If so, every step we take toward understanding the universe, every equation, every discovery, every late-night conversation about the nature of reality, could be part of what the simulation was designed to create. And if that's true, then even our wondering matters. Even now, sitting here thinking about this, you could be doing exactly what the system was built for, turning the rules of the universe back on themselves, using a mind that emerged from the framework to examine the framework. But it's also possible there's no deeper design, that what we call meaning isn't given to us from the outside, but something we create for ourselves. If that's the case, then the goal is whatever we decide it is: to build, to learn, to live, to turn a structure of rules into a place where something truly human can exist. In the end, maybe that's the one conclusion that doesn't depend on whether or not this is a simulation. Because either way, the question leads you to the same place. Purpose isn't something you find hidden behind the code. It's what you bring to it. Whether this world was programmed or not, it's the world you're in. It's yours to navigate, yours to fill with meaning, yours to explore, until the rules themselves are no longer enough to contain what you've made of it. If there's one thing that becomes clear the deeper you look at the universe, it's how astonishingly elegant it is. Whether or not it was programmed, whether or not anyone is behind it, the rules that shape this reality don't just work, they do so with a kind of quiet, breathtaking precision. And that precision has a beauty all its own. Look at the laws of physics. They are simple enough to be written on a chalkboard, but powerful enough to govern everything from the smallest particle to the largest galaxy. Gravity bends the paths of planets, and light itself with the same equation. The rules of quantum mechanics, as strange as they are, hold perfectly for every electron in the universe. It's almost as if the entire cosmos runs on an elegant minimal script. Compact, efficient, but endlessly rich in what it can create. Even if this is not a simulation, it feels engineered in a way that invites awe. There is no wasted motion in the structure of reality. Stars ignite because the equations of nuclear fusion demand it. Galaxies spiral because the math of gravity will not let them do otherwise. Snowflakes form patterns so intricate that no two are ever quite the same, and yet every one of them still follows the same underlying rules. And that's what makes the idea of the universe's code so compelling. Because in programming, you start with a small set of instructions. Those instructions interact, combine, and repeat until they generate complexity far beyond what you could see in the beginning. The same thing happens here. From a handful of fundamental laws, everything we know has emerged. Atoms, chemistry, life, thought, and the very ability to stand back and marvel at it all. When you look at the world this way, it doesn't matter whether you call it code, mathematics, or simply nature. The beauty lies in how all of it fits together so cleanly that it allows a universe to exist without falling apart. Even chaos has its own kind of order. Turbulent storms follow fluid dynamics. Random mutations follow the rules of biology. Every piece of apparent disorder rests on a foundation of laws that never break. This is why some scientists say that, even without proof, the simulation question is worth thinking about. Not because we need the answer, but because the act of asking it forces us to notice the structure we're standing on. When you wonder whether this world is built, you start paying attention to how finely it's tuned. And whether it's designed or not, that tuning is hard to ignore. Think about the constants of the universe, the speed of light, the strength of gravity, the charge of an electron. Change any one of them even slightly, and stars might not form, atoms might not bind, and life might never appear. Yet here they are, balanced with an exactness that allows not only existence, but the kind of existence that can look around and ask these questions. Even if there's no grand design, that balance is extraordinary. It means that from the smallest bits of information, the universe can unfold into something vast enough to hold galaxies and delicate enough to create consciousness. If that isn't beautiful, what is? And this beauty isn't only written in the far-off and abstract. You can see it in the way sunlight scatters through a window, in the fractal veins of a leaf, in the quiet predictability of the tides. These are the local expressions of the same rules that guide the entire cosmos, and they're no less remarkable for being ordinary. That's what makes this line of thought so comforting. Whether or not there's a programmer, whether or not this is a simulation, the framework we live in is astonishingly coherent. And that coherence is what makes the world not just livable, but understandable. We're not trapped in chaos. We're living inside something that can be studied, mapped, and appreciated down to its smallest parts. And from that perspective, the question of whether it's real or simulated almost starts to fade. Because either way, what you're left with is the same thing. A world whose rules are so precise that they've built something far larger and stranger than any of us. Even if the universe is built on rules, there are moments that feel like they exist outside of them. Moments that don't seem reducible to mathematics or physics or any kind of framework at all. They're the pieces of life that feel immediate, personal, and undeniable, so vivid that they can make the question of whether this is a simulation seem almost irrelevant. Think about laughter. Not the kind you force in conversation, but the kind that comes unexpectedly, the kind that takes over your whole body until you're breathless and aching from it. There's nothing in that moment that feels like it belongs to a program. It doesn't feel calculated. It feels raw and uncontrollable, a flash of something purely alive. Or think about love. However you define it, whatever shape it takes, it doesn't feel like it could come from equations. It isn't logical or predictable. It's stubborn and irrational, and at times, overwhelming. And yet it's one of the most powerful forces in a human life. You can describe the biology behind it, the chemicals in the brain, the evolutionary reasons why it exists, but none of that explains the experience itself. Even simple, quiet moments have the same quality. Standing outside on a cold night, watching your breath curl into the air, hearing a song that reminds you of a time and place you thought you'd forgotten, feeling the weight of a hand in yours and realizing in that second that you are here and someone else is here with you. These are not abstract questions. They are not lines of code. They are the things that anchor you, the things that make you forget for a while that any bigger mystery exists at all. And that's what makes them so important. Because even if the universe is a simulation, these moments are not illusions. They're not fake. They're as real as anything can be, because you live them, you feel them. And in a strange way, they might even be the point. If this were a simulation, what would matter more? The structure of the system, or what happens inside it? A program can be elegant, but its elegance is meaningless without something running through it, something that gives it life. In that sense, every laugh, every conversation, every fleeting memory might be exactly what all of this was built to hold. It's easy to lose sight of that when you focus too much on the machinery of the universe. You can get caught up in the math, in the quantum rules, in the theories about hidden layers and hypothetical architects. But when you stop and look at the simplest human experiences, you realize that none of those bigger questions change them. Whether this world is natural or simulated, you still feel the warmth of sunlight, the rhythm of your own breath, the quiet comfort of knowing you are not alone. That's why, for some people, the simulation question isn't unsettling at all. Even if it turned out to be true, nothing about these moments would vanish. They would still be here, just as real and solid as they've always been. And maybe that's the most grounding part of this entire thought. The mystery of the universe is vast. It stretches farther than anyone can fully imagine. But at the center of it, there are small things that don't need explaining. You don't have to solve the nature of reality to feel the pull of them. You only have to live them. So perhaps the real lesson isn't about whether this world is simulated or not. Maybe it's about remembering that, in the middle of all this speculation, there are things you don't need to question at all. A voice you trust, a memory that stays with you. A quiet moment that feels so unmistakably yours that no theory in the world could ever take it away. And once you see that, the simulation question changes. It doesn't vanish, but it softens. It becomes less about proving something cosmic, and more about seeing how, even in a universe that might be made of code, there is still something unshakably human running through it. After everything we've explored, from the smallest particles to the largest questions, there's a simple truth that's hard to avoid. Even if the universe were a simulation, it wouldn't change the way you live in it. Reality, no matter what it's made of, still feels the same from the inside. The air you breathe doesn't feel like information. The ground beneath you doesn't feel like code. You don't experience your world as mathematics or algorithms. You experience it as sound, sight, touch, and memory. You feel joy, loss, curiosity, and comfort. None of that would vanish if someone one day proved beyond doubt that everything around you was being generated by some unimaginably complex system. You'd still wake up tomorrow to the same sky, the same familiar details of your life, the same small moments that make up what it means to be human. That's why some people see the simulation hypothesis not as a threat but as a kind of perspective shift. If it turned out to be true, it wouldn't make the world less real. It would simply mean that real is bigger than we thought. Whether this is base reality or not, it is still our reality. And that's what matters. You can even see it in the way we already live with abstractions without losing ourselves in them. Take technology. Most of us spend hours every day inside digital spaces, watching screens, sending messages, moving through worlds that exist only as data, and yet our feelings inside those spaces are real. A conversation held through text still carries meaning. A song streamed from a server still makes you feel something. The framework doesn't erase the experience. If anything, it's what makes the experience possible. The same is true of this universe. If it is simulated, the fact that it's running according to some hidden code doesn't make it less valid. It simply gives us another way to understand the stage we're standing on. You don't dismiss a story because it's written in words. The words are what allow the story to exist. And maybe that's the heart of it. What we call reality is defined not by what it's made of, but by what it gives us. Whether it's particles or pixels, atoms or algorithms, it is the world we live in. It is where we think, feel, and move through time. It's where we hold the moments that matter most, the ones that are immune to any larger question about what's behind it all. That's why, for many, this question ends up being less about finding proof and more about finding perspective. Because in the end, whether the universe is simulated or not doesn't change the fact that you are here. It doesn't change the sound of your own breath or the quiet rhythm of your heart. It doesn't change the way the world looks when the light hits it just right and everything feels still for a moment. In fact, there's a strange kind of comfort in that. If this world is real, it's ours. If it's simulated, it's still ours. Either way, the experience is the same and it belongs to you. And maybe that's why this question has lasted so long. Because in the end, it's not really about the answer. It's about the way the question pulls you back to the simplest truth. No matter what reality is, you're living it. You don't have to solve it to feel it. From here, the conversation turns again, not to what this universe is made of, or even who might have made it, but to something quieter. If this world runs on rules, and if there's something larger behind those rules, What would it sound like if we tried to listen for it? Not with experiments or equations, but with the same kind of stillness that lets you notice the world in the first place. If there is something behind this universe, an architect, a designer, or even an impersonal system, how would we ever notice it? Not by looking for obvious signs, not by expecting the sky to split open, or for the rules of physics to suddenly break. If there is anything outside this world, it wouldn't announce itself so easily. It would be quieter than that, hidden in the way everything already works. When people talk about listening for the programmer, they don't mean hearing a literal voice. They mean paying attention to the details of reality so closely that you start to see the shape of whatever might be holding it together, noticing the way the laws of physics fit together as if they were written with intent. Watching the way complexity arises from simplicity, how from a few fundamental rules come stars, planets, life and minds capable of asking these very questions. It's not the kind of listening you do with your ears, it's the kind that happens when you step back far enough to see the pattern, the same way you might look at a painting up close and see only brush strokes, but from a distance the whole picture suddenly emerges. Some scientists think that if there is a deeper structure behind reality, we might catch glimpses of it in the data. The smallest anomalies in cosmic radiation, the faintest irregularities in quantum behavior, the limits of space and time themselves. Others believe that if we ever do hear the programmer, it will be through mathematics. In the way equations describe the universe with such precision, it feels as if they were discovered, not invented. But there's another kind of listening too, one that doesn't require telescopes or particle accelerators. It's the kind that happens in moments of stillness, when you look at the world and feel that strange mix of familiarity and mystery. A night sky full of stars, the quiet hum of a city at dawn, a moment of silence where nothing is happening, and yet somehow you can't shake the sense that there's something vast behind it all. Something woven into the structure of everything. It may not be proof, it may never be proof, but the act of listening itself is enough to change the way you see the world. You stop expecting answers to arrive with certainty, and instead, you start noticing what's already here. The code-like precision of the laws of nature, the seamless order that holds reality together, the simple fact that anything exists at all. And maybe that's what it means to listen for the programmer, not to wait for a voice, but to see the signature in the silence. Because if there is something out there, it doesn't need to speak. It's already written into every atom, every ray of light, every moment that unfolds without breaking the rules. If this is a simulation, then whoever, or whatever, built it has left no easy way out. No hidden doors, no obvious signs. But maybe that's because there's nothing to escape from. Maybe the point was never to look beyond the system, but to live inside it, to move through it, to see how far you can follow its patterns, and to wonder quietly about the source without ever needing to find it. That's why the question never really ends, not because it can't be answered, but because it doesn't need to be. Listening is enough. Wondering is enough. Even if the programmer never reveals itself, the world it has built is already here, running perfectly, full of mysteries that will take lifetimes to explore. And as you sit with that thought, the simulation question itself begins to soften one last time. It stops being about answers and starts feeling like an invitation to rest in the mystery, to stop searching for the edge of the code and simply let yourself exist within it exactly as you are. At the end of all this, the question is still here. Are we living in a simulation? After everything we've explored, the philosophers, the physics, the information, the mathematics, the moments that feel too real to be reduced to any theory, there's still no definitive answer. And maybe that's exactly how it's supposed to be. Some questions are not meant to be solved quickly. They're meant to stay with you, to be returned to now and then, like a familiar path you walk, not because you expect to find anything new at the end of it, but because it's worth walking. This is one of those questions. Whether or not we're simulated, the act of wondering changes the way you see the world. It slows you down. It draws your attention to the structure of reality, to the details you usually pass without noticing, to the fact that there is something rather than nothing, and that you are here to witness it. And in that sense, the question already gives you what you're looking for. Not an answer, but perspective. Whether or not the universe is a simulation, it is still a place of perfect order and endless possibility. It is still a place where you can laugh and love and sit in quiet wonder at the way everything fits together. Maybe that's enough. Maybe the purpose of asking is not to pull back the curtain, but to realize there is a curtain at all, to see that reality is deeper and stranger than it looks on the surface, and to feel just a little bit smaller, but also a little more connected to whatever it is that holds it all in place. Because in the end, nothing about this mystery changes the fact that you're here now, breathing in a world that works so perfectly you rarely stop to think about it. Whether it's atoms or algorithms, code or nature, this is the reality you live in, and it's real in every way that matters. So, let the question stay open. Let it sit quietly in the background, not demanding an answer, but simply reminding you that there's more to the universe than you'll ever fully grasp. And that's okay. You don't need to solve it. You only need to rest in it. Close your eyes if you haven't already. Let the edges of your thoughts soften. Let the weight of the question fade, not because it's gone, but because you've given it permission to be what it is, a mystery that holds you rather than a problem you have to solve. Somewhere, deep down, the rules are still running, the stars are still burning, the code, if there is one, hums on without pause, and above it all, you are here, in this moment, safe inside the quiet rhythm of a universe that works exactly as it should. Rest in that. Rest in the mystery. If you're still here, listening, letting these thoughts settle, thank you for staying with me through this quiet journey. Maybe you came looking for answers, or maybe you just wanted something to ease you into the stillness of the night. Either way, I hope this gave you what you needed, a space to slow down, to think, or simply to rest. If you've been listening while trying to fall asleep, you don't need to do anything else. Just stay where you are. Let the question drift away for now. The universe will still be here in the morning, running its quiet, perfect patterns whether or not you think about them. And if you're awake and want more nights like this, you know where to find them. You can like this, subscribe if you want to join me again, or even share where in the world you're listening from. I always enjoy seeing those little markers, scattered across the map, tiny points of connection in a vast, mysterious universe. But for now, there's nothing else to do. Let the world fade out. Let yourself sink into the calm that comes when you stop trying to solve everything and simply let it be. Good night, rest well, and remember, whatever this universe is, it's yours to live in.